All right, so I'm excited for today because I really want to bring all this home for you guys today. So let me try and make this make sense. I'm gonna do a little review, but it'll go right into what we covered already to kind of make it all come together. So we introduced momentum last class, right? So momentum, as I said before, was mass in motion equal to an object's mass times its velocity, right? So literally, if you think like you're running, right? And if you were just to keep running, right? You consider that momentum as because like you will be moving and staying in motion in that same direction, right? That same direction, that same velocity going there, right? That relates is kind of like to Newton's first law, right? To where we have the concept of an object in motion stays in motion unless acted by unbalanced force. So if you think about momentum, the forces are typically you could say balanced in that system, right? So where now, if you whatever direction you're going and how fast you're going, you would just keep going that way, right? So we take that constant momentum, right? We break it down. Momentum is equal to mass times velocity, and then its units are right there, kilograms meters per second. It's also a vector quantity, right? And momentum is conserved in the system. So then we did a couple problems. We've seen that mass and velocity pretty much are the two determinant factors for momentum. And then we also did some calculations where we've seen, hey, if you change the object's mass, it increases the momentum by a factor of blah, blah, blah. If you change the object's velocity, it increases a factor two the same way, right? Then we just did a simple momentum calculation. And I think we stopped perfect. Yes, we stopped right here, right? Mass times velocity. That's very simple for momentum, right? But when we start getting into momentum, we can start talking about things called like the change of momentum, or also talking about the impulse, right? Now, what are these two quantities, right? So now I want us to take a step back and go all the way back to when we start talking about Newton's second law, right? So I said momentum is kind of similar to Newton's first law, right? Because the object of motion stays in motion unless unacted by unbalanced force. So in the first law, we talk about balanced forces, right? But what happens if an unbalanced force acts upon an object that's already moving or has a certain type of momentum, right? So when forces are unbalanced, is Newton's second law, the net force is equal to the mass of the object times the acceleration of the object. So the sum of the force is equal to mass times acceleration. That's Newton's second law. So now also recall the definitional equation for an acceleration, right? So we also know that acceleration is equal to the change in velocity over time. And it's also a vector quantity, change of velocity over time. So when we look at Newton's second law, right? And then if we change the acceleration to its definitional equation, which is velocity over time, we can do some simple algebra. So where if we multiply time by each side, we move time onto the other side. So now we have the sum of the forces times time is now equal to mass times the change of velocity. When we do that, right, we have these two quantities that we talk about that are related to momentum, right? We have impulse, which is the sum of the forces times over time. Sorry, times time. And we have a change in momentum, which is by delta P is equal to mass times the change of velocity, right? So now we have these two quantities to where now we can start to talk about a system and talk about a system that's conserved at first, but when a force is brought into it, how it affects the system in whole over time, right? And it's something to notice too, if you see how we had it in the beginning, we got impulse and change of momentum from the same Newton's second law equation, right? So basically we can conclude that impulse is equal to the change of momentum. All right, so now let's keep going to where now, let's just do a simple problem, right? So everything that I just said, right? We already know momentum is equal to mass times velocity.
Could you go back real quick?
Right here.
Yeah, I was trying to get the last thing at the bottom really, really quick. Give me 1 second. Okay, thank you.
So now we got these concepts, right? We got momentum is equal to mass times velocity, impulse is equal to force, sum of the forces times the time, and then we have change of momentum, which is equal to the mass times the change of velocity, right? So taking all of these, let's put these all together and to create this statement that basically describes everything that we talked about and sums it up, right? So we want to insert these words in the 4 blanks in the sentence, right? We got mass, momentum, acceleration, time, impact, weight, impulse, and force, right? And it says not every word will be used, right? So in a collision, an object's experience is a what?
The impact.
Impact. Okay, let's try. Let's put that in there and see an impact. Let's see an impact, right? An impact acting for a certain amount of
Time.
which is known as a or an,
Force.
say force. Okay.
No,
It's
it wouldn't be force because we're talking about time. So if it's acting for a certain amount of time, it will be known as, would it be acceleration?
let's just put acceleration to see how it goes. So a collision, an object experiences an impact acting for a certain amount of time, which is known as an acceleration. It serves to change the what?
Momentum.
Momentum of the object, right? Okay, now let's go backwards, right? It serves to change the momentum of the object. What do we say here that change in momentum is also equal to?
Oh, impulse.
Impulse, right? So if we say it serves to change the momentum of the object, then it should be known as a what?
Impulse.
Impulse, right? And an impulse is acting for a certain amount of
Time.
time, and it experiences a what? Look at the equation for impulse right here.
Force.
Force, right? So now I'll say that all together. In a collision, an object experiences a force acting for a certain amount of time, and which is known as an impulse. It serves to change the momentum of the object. See how that goes together? And I liked how we did it the first time and actually just put in the words. But once we did it, we actually were able to go backwards and use the definitions to be able to get us there. Change in momentum is equal to impulse. An impulse is a force for a certain amount of time. So if you're ever confused, you can use these equations to kind of walk yourself backwards or talk yourself into the right answer. And I hope that's what you've seen in this one. But really understand that impulse and change in momentum are the same thing. Now, let's do a problem where we kind of see that similarity, right? So you want to calculate the impulse in each situation, right? So we got the same equations over to the right? Calculate the impulse experienced by 65.8 kilogram halfback encountering a force of 125 newtons for 0.35 seconds. So let's think about it, right? What did they give us? I see 65.8 kilograms. I see that's a mass, right? And then I also see they gave us a force, right? And they gave us 0.35 seconds, which is a time. So I got, hold on.
Will we use impulse?
Yes. So what am I doing? I'm looking for this. Give me a second. Just how I'm doing right here. I have a force, I have a time, and I have a mass. So what's given to me, I have a mass,
The force and the time.
force, and a time, right? So now that I have force and a time, what can I use? Also, what am I trying to find? What's my unknown?
I really don't know what are we trying to figure out the force?
What are we trying to figure out? What does it say? Calculate the
mass?
What does it say? Read the problem.
Oh, impulse, because we already have the mass.
Impulse, right? Calculate the impulse. So now I'm trying to calculate the impulse. What do we need to calculate the impulse?
The
Out of
force.
these equations. Force and time, right? So we got force and time. Sorry, we need force and time, but we have force and time here, right? So now if I just pull those out, impulse is equal to the sum of the forces times time, right? What is the total force in this system?
1025 newtons.
There we go. And what is the time that this force is exerted?
0.350 seconds.
Exactly. So all I should do with those is just multiply them. So now what is the impulse in my system?
Hold on, I gotta calculate it. Hold on.
It's 358.75.
358.75. 358.75 kilogram meters per second.
Would it be meters per second?
Kilograms meter per second.
Oh,
Okay. So now that we got that, right? That was just simple. We were able to just go ahead and solve for impulse by just doing force times time, right? Let's look at the next one, though. What is the impulse experienced by a 0.168 kilogram tennis ball encountering a force of 126 newtons that changes its velocity by 61.8 meters per second? So when we look at what we have, right, we're given what?
the velocity, the newtons,
Come back. What does that say?
it changes its velocity by
So what did we get?
61.8.
So what did we get? Did we get the velocity or we get the?
We got the mass.
Okay, yes, we have the mass, but come back to that velocity thing you just said.
Just know we got the mass, the force, and I don't know.
It would be delta V, like the change in velocity.
Yes, not just velocity, but the change of velocity. And it literally says it changes its velocity. So that doesn't mean that it is going at that velocity. It changes its velocity. So it's initial and it's final. You subtract those two, you get actually 61.8 meters per second. So that's what that means right there, right? So now this one, right? What's our unknown? We're trying to find the what?
Velocity.
What are we trying to find?
Impulse.
Still trying to find impulse, right? Now, this one right here, this is where an assumption comes in. The equation for impulse is what?
Force times change over time.
Force times time, right? Do we have a time right now?
Yeah.
Where do you see a time?
The last one we just got.
Oh, this is a different problem. Go to this problem. This is a different problem.
Oh, I thought it was a two-step problem. Oh, okay. Well, then say that again.
Do we have a time?
No.
So we don't have a time, right? But we need to find the impulse. How can we do that?
Mass times velocity.
Mass times velocity or mass times
Change in velocity.
change of velocity, because we're saying that impulse is equal to what?
Change in velocity by 61.8.
Hold on. Don't do it with the numbers. This is a concept, right? Take away the numbers. It's not math. There's a concept I need you to get. Impulse is also equal to what?
Change in momentum over time.
Impulse is equal to the change in momentum. Those are equal, right? So then when we break those down, the impulse is also equal to the change in momentum, which is mass times the change in velocity. So do we have a mass?
Yeah.
Do we have a change in velocity?
Yeah.
So now we could just multiply those two together. .168 times 61.8. And we get what?
10.38.
10.38
Yeah.
kilograms meters per second. All right, hold on. There we go. Everybody able to see that?
I don't think that's the answers we got.
What do we get in the first one?
Oh yeah, they just rounded it, but I'm looking at the second answer. Yeah, they rounded it too. Okay.
Now, the math, very trivial, right? But with that one concept that I want you to get is exactly what we talked about right here, right? Impulse is equal to the change in momentum. So when we go back and forth, right, even with this, right, understanding that object experience a force for a certain amount of time is an impulse, and that serves to change the momentum of the object. So you're going at a certain speed, you're going at a certain velocity, you're traveling in a certain direction, and you literally feel an impulse. What is that impulse? A force over time. A force over a certain amount of time that causes you to change the momentum. That's you colliding into a wall. That's a car crash. Or you getting punched in the face with a fist. All those things cause you to then, in turn, change your momentum. And we see that here when we look at the math. The math just backs it up that an impulse is equal to a change in momentum. But how does that come to we see in the actual situation? That's what we're going to start looking at in this problem right here, right? We want to evaluate how objects move when they feel an impulse or a change in momentum. So we want to go through this scenario, right? Well, we know the first one is billiards, right? Billiards. You got a 7-ball collides with an 8-ball, right? So we want to identify the impulse, change of momentum, and momentum in the system at each point. So when we look at that first initial one, right? This is the initial motion, right? We're starting off. And remember, everything is conserved in the system, right? So now, when we have our first 7-ball, right? It has a mass and it has a velocity. Therefore, we can find the momentum of that. Hold on. We could find that initial momentum, right? The momentum is equal to mass times velocity. What's the mass?
7. Oh no. The mass is 11. I'm at 0.1 kg. Sorry.
0.1. And then what's the velocity?
4.
4. So when we do that, we have a total momentum of what?
Whatever 1 times 0.1 times 4 is. Hold on.
Right? Is that right?
Yeah.
All right. So now we get 0.4 kilograms, right? Now let's look at this, right? We could also find the momentum after the impact with the ball, right? So now it goes, did the mass change at all?
No.
No, but what did change?
The velocity.
So now we have 0.1 as the mass, and then the velocity now instead of 4 is what?
1.
1. So now we could look at it as 0.1 times 1, which is
1.
0.1. So now we have 0.1, right? 0.1 here, and then 0.4 here. All right, let me erase it to make it clean. So you got 0.1, 0.4, right? Now we said this, right? Let's do this 2 ways, right? We know the change in momentum is equal to mass times change of velocity. Did our mass change when we hit the object? Did our mass change at all when we hit the object?
What was the question? Did the mass change?
When we hit the object?
Um, no.
No, so it's still 0.1, right? Now, when we hit the object, did our velocity change?
Yeah.
From what to what?
0.4 to, I meant from 4 to 1.
From 4 to 1, right? So our final was 1 and our initial was 4, right? So if I do this in calculator, right, I got 0.1 times what's 1 minus 4? 1 minus 4 particularly. 1 minus 4.
Why do we do 1 minus 4 again?
Because we want to do the final, the change of velocity. Remember this? Change of velocity is equal to final minus the initial.
Okay.
What is the initial velocity?
The 4,
4. And what was the final?
the 1.
1. So then we do 1 minus 4 to find the change. Now, what is the change in velocity?
What changes to 3? Negative 3?
Good. -3. This is important because momentum is a vector quantity, right? So now, what is our change in momentum? We got 0.1 times -3.
You said where did you change it?
No, what is it, the value? We got 0.1 minus -3. Sorry, 0.1 times -3.
Negative 0.3.
-0.3. Good.
Can we just do the final momentum minus the initial?
Hold on. That's what I was about to show. Yes, you are on the right thing. Yes. So we got -0.3, right? And that's how we calculate it, right? But now, what did we just see? Actually, just said it, right? We initially calculated the individual momentums, right? Just like how we said change in velocity is the final velocity minus initial velocity. What do you think change in momentum is also equal to?
I don't even know.
Take a wild guess.
Change in momentum is equal to velocity too.
Let's not think about velocity. Let's change it because we're talking about what quantity? Momentum, right? So change of velocity is equal to the final velocity minus the initial velocity. What would you think the change in momentum will also be equal to?
It would be mass times velocity. Change
Yes,
in velocity.
mass times change of velocity, right? But also just think about what this delta means. Change, right? So to change and find a change in something, you have to find out from its end to its start, what's the difference, right? So how would you find the difference or change in momentum? You have to find its
Mass times the change in velocity.
yes, but there's another way we could do it. Imagine we have two different momentums, right? How will we find a change between these two momentums? We would just subtract them, right? So now if we think about the change of momentum, we could find the change of momentum by subtracting the difference between two momentums, right? More importantly, the final momentum minus the initial momentum. Does that make sense?
No.
What's confusing about that?
I guess it's the same thing as the final velocity and the initial velocity. It's just a different word.
That's exactly what I'm saying. It's exactly that. Yes. I wanted you to see that.
Okay.
So there's multiple ways to find a change in momentum, right? You can use the mass times change in velocity, or you could just find the individual momentums and just subtract them. That's what we have at the bottom, right? And how do we know that works? Because look, momentum is also equal to the initial momentum. Sorry, the final momentum subtracted by the initial momentum. What did we say the initial momentum was?
4.
Or
0.4.
0.4, right? What did we say the final momentum was?
The 0.1.
0.1, right? What's 0.1 minus 0.4?
It will still be 0.3.
Positive or negative?
Oh, negative.
Negative 0.3. So now we were able to get the same answer, but just two different ways. That's what I wanted you to see. So you got change in momentum is equal to, change in momentum is equal to mass times change in velocity, but it's also equal to the final momentum subtracted by initial momentum. So we just need to know that as well too.
Okay, so we just did them both those types of problems in just two different ways. Okay.
Correct. Now remember what I said earlier. Change in momentum is also equal to what?
Impulse.
Impulse, right? So now if we know that change in momentum is equal to 0.3 kilogram meters per second, what would be the impulse?
The same thing?
Exactly. And specifically negative 0.3. Sorry, I meant to add the negative 2. Negative 0.3. Now, let's think logically, right? When I say negative 0.3 kilogram meters per second, what does that really mean in context of us hitting the 8 ball?
It's going backwards?
Exactly, yes. So I'm going one way. As soon as it hits the 8 ball, it's going to fly backwards. Does that make sense?
Yeah.
I knew the answer, but I still would like to see it in person just to see.
You want me to bring some billiards and hit them together? I can do that. But that's exactly what it is. Like if you playing pool for real and you hit the ball, and when it collides with another ball and it goes backwards, it goes different, like backwards, that'd be like a negative change in momentum.
Okay.
That's an exact example. So now let's do the same thing, right? And this one is a good example. This next one, when it comes to just thinking logically, because the person who catches this ball, right, she's on skates, right? So now that she's on ice skates, as soon as she's catching it, she's going to start moving, right? So now let's look at it, right? What's the initial momentum when we first have the medicine ball and it's flying through the air? We'll start out. Momentum equals to mass times velocity. Do we have a mass?
10.
10. Or what is our velocity? Initial velocity.
6.
So now our initial momentum is what?
60.
60. Now let's try and look and see what they gave us, right? So now we don't have, do we have a final velocity?
No, not yet.
But what do we have?
We have initial velocity.
And what else do we have?
We have a mass.
What else do we have?
Momentum.
We have momentum. We just calculated it. What else do we have?
The impulse.
The impulse, right? So this impulse is negative 50 newtons per second, right? Same as kilogram meters per second, right? So that's the impulse, right? Now, we said earlier, impulse is equal to what?
Change in momentum.
Change in momentum. So if the impulse is negative 50 newtons per second, then the change in impulse must also be
Negative 50.
negative 50, right? So now we need to find that velocity, right? But there's two ways we could do this, right? So let's go the first way. We know that initial is 60, right? I know that this is 60. And I know that my change in my change in momentum is negative 50. So if I come over here, I could do this to where I have my change in momentum is also equal to actually, let me do it this way so it's easier because we can go the way that you see on the screen. My change in momentum is equal to my mass times my velocity, right? I know that my change in momentum is negative 50. I also know that my mass is still the same. We can see in the diagram, 10. So now I need to figure out what my change in velocity is. I see times 10, so I do division by 10. Ooh, that was ugly. I don't know why I just did that. What is 50 divided by 10? Negative 50 divided by 10.
5.
Negative 5. So my change in velocity is negative 5 meters per second. What does that mean in regards to what my final velocity will be?
I don't know. Wait, what? So
Hold on. If my change in velocity is negative 5 meters per second, what does that mean in regards to my final velocity?
You just add them, so it would be -5.
So minus 5 is my change in velocity. And I want to
6
find my
minus 5.
final velocity. What was my initial velocity?
6.
6.
6, right? So now, if I want to find my final velocity, what do I need to do with this minus 6? I need to
I don't know. Subtract
hold on.
it.
Add it to the other side.
Uh,
Because I see a subtraction, so I do addition. Now, what is negative 5 plus 6?
1.
1. So that means my final velocity is 1 meters per second. Now, let's go back. Does that make sense? For this to be 1, this is 6, and my change was in velocity was negative 5. Don't do too much math. Just look at it, right? Did my velocity change by negative 5 if this is 6 and this is 1?
yeah.
Okay. So that makes sense. Now with us finding that, right? What is this final velocity? Sorry, final momentum. It would be momentum equals to mass times velocity. My mass is what?
10.
10. And my final velocity is what?
1.
1.
1. So now my momentum would be what?
10.
10. Good. Now let's go back here, right? We said that this one was 60. And impulse equal to the change of momentum, which is negative 50. Do our numbers match up at the very end?
I don't understand the end.
Hold on. Change of momentum.
As in 60 minus 50 equals 10. So yeah, it matches.
Is also equal to the final momentum minus the initial momentum. What was our initial momentum?
10.
That's the mass. The initial momentum, we had to find it, remember?
Hold on.
10 times
10 times
60.
6, which is how much?
60.
60.
60. And then we did the final, which was 10 times
1.
1.
1, which is how much?
10.
10. Now, if I take my initial, which was 60, and subtract that from my final, which is 10, I get 10 minus 60, which is equal to how much?
Oh, 50.
Positive or negative?
Negative.
Negative. Is that not what we got right here? Or they told us it was?
Yeah.
Putting it all together, right? Now you could have went the other way and went and find the two individual momentums and then found the velocity at the end, which is basically you would have just did here and used the change of momentum, right? Since you knew it was going to be 50, right? And you could have said that did we know the initial was 60, that this was going to be 10. And by knowing that this was going to be 10, then you could come up that this will be 1. So that would be the other way to go backwards. But as you can see, you could do either way that you want, right? To find an answer. But all you got to do, like in a situation like this, because it's conserved, you just sit here and you try and make sure all the numbers match up. Does that make sense?
Mm-hmm.
All right. Let's do another problem like this, but this one is specific to where you see something kind of do like a rebound, right? To where it bounces off of something, right? That first one we just did was, the last one we just did was something like catching it, right? Let's do a scenario like where it rebounds off. So you want to determine the change, impulse, change, momentum in this situation, right? It's the same thing with this tennis ball, right? So it's multiple points, right? So the tennis ball is at rest when experiencing a forward force to set it in motion. So it was at rest, right? So that was like Newton's first law. Staying in motion until it feels a force to set it in motion, right? So now it has an unbalanced force acting upon it. That's that impulse. So now we get it to move, right? So it strikes a wall where it encounters a force that slows it down and finally turns it around and sends it backwards. So let's go through each part of it and talk about this. So now it stopped, right? So when it stopped, technically when it's at rest and it stopped, what is this velocity?
0.
0. So if it has 0 velocity, will it have momentum?
No.
No. So we can assume that this would be 0, right? Then all of a sudden, right, we have an applied force of 60 newtons for 1 second. So we want to figure out what the momentum is when it's moving to the right, right? To figure out the momentum right here, right, we need to figure out how the momentum changes between P2 and P1, right? We know that P1 is equal to 0. So we need to find out our change of momentum, and that'll be what it is for P2. Does that make sense?
What? I didn't get. I understood the first part, the P2 minus P1.
What is P1?
0.
0. So therefore, because this is 0, this will just go away, and we'll just say the change of momentum for this scenario right here is just equal to P2. Does that make sense?
Not really, but I don't want
Hold
to
on.
overstep.
Look, P1. What's P2 minus 0?
It's still P2.
Yeah, that's all I'm saying. So what happens with the 0? Does it stay there or does it go away?
It just goes away.
So now we got the change of momentum is equal to P2. Does that make sense now?
Yeah.
So that's what I'm saying right here. So all to find out what this one is, we need to find out what the change of momentum is. Well, let's go back. Change of momentum is equal to, like we say here, mass times change of velocity. Do we know the mass?
Yeah.
What's the mass? Do you see a mass?
No, it's no mass. It's a force.
Okay, you see a force. Do you see a velocity, change of velocity? You see delta V?
No.
But what did you see that you said you did see? You see the what?
The momentum, that's 0.
Hold on. That's 0. But what did you just say? The F word you just said. You see a what?
Force and time.
Force and time. What does force and time look like?
Impulse.
Impulse. And impulse is also equal to what?
Momentum.
Momentum or
Change in momentum.
change in momentum. That's very key, right? Impulse is equal to the change in momentum. So if I was to find the impulse, I should be able to find what as well?
Momentum.
Momentum or the
Change in momentum.
change in momentum. Very specific, right? So now what is that force that we experience?
The hit from the ball.
Yes, sorry. How much is the force that we experience?
60.
60 newtons, right? And how long do we experience that force?
1.1 second.
0.1 seconds, right? So now if we do 60 times 0.1, we get a change in momentum of how much?
Oh, I don't know the answer.
It's 6.
6, right? And we also experience an impulse of how much?
So we also experience the impulse of 6.
6, the same, right? So now we know the change in momentum is 6, right? So let's go back over here, right? We said that because the momentum right here in the beginning, our initial was 0, that if we find a change in momentum, it will be equal to the final momentum. We just found that the change in momentum is equal to 6. So how much is the momentum at P2?
6.
Correct. So now we know that this momentum here is 6. Kilogram newtons per second. So sorry, kilogram meters per second or kilogram newtons per second. That's the unit. I'm just not writing the unit just so you know. But 6, right? So now we're here. Go ahead.
So for this answer, all the ones would just be 6.
Correct.
Okay.
Now let's think about this, right? So now we go and what did it say? It encounters a force that slows it down, right? So now we get here, it's traveling, moving right, and then all of a sudden it encounters a force. What happens? It hits the wall, right? So now it hits the wall. Once it hits the wall, we see that it experiences a velocity of how much?
0.
0, right? So now with a velocity of 0, how much do we expect this momentum to be?
0.
Now logically, what happens when it hits the wall?
It stops and bounces back faster.
Before it bounces back, it does what?
Stops.
Stops. Does that make sense when it's happening at 0 velocity?
Wait, could you say that again?
Think about it. It has a 0 velocity, but what does that mean? And logically, that means it did what? You just said it. It stopped,
Stop.
right? So that's what I want you to make sure that you understand logically. Okay, this is the point where it stops. Now the bounces back is the next part. We're about to get to that. But right now, we see that the ball hits the wall and it stops. So momentum is 0. But what was its momentum beforehand?
6.
So did the momentum change?
Yeah.
By how much?
6.
6, right? Because its initial was 6 and its final was what?
0.
0. 0 minus 6 is how much?
6.
6 positive or negative?
Negative.
Negative 6, right? So I could say my change momentum is negative 6. If my change momentum is negative 6, we also said that change momentum is equal to what?
Force times to impulse.
Impulse, right? So if my change in momentum is negative 6, then my impulse must also be
Negative 6.
negative 6. Now I have my impulse, but do we have a force for how much the force but it hits the wall with?
No.
No, but can we find it?
Yeah.
I know that my impulse was negative 6 and I have a force that I'm trying to find, but do I have a time?
0.05 seconds.
0.05 seconds. I see multiplication, so I'm going to do division. So if I divide each side by 0.05, I should be able to find my force. What do we get when you divide 6 by 0.05?
120.
120.
Negative 120.
Negative 120. The negative just tells us the direction. I'm about to erase all this so it can be clean. We was at what? 0. Then this was 6. This was 6. 6. This was 120. This was 0. -6. -6. Right? So now our object comes out, and just like Courtney said, right, it's going to bounce off the wall and go. It's going to hit the wall, slow down, and then bounce off, right? So that's what this moving left is, right? It's saying it's bouncing off. So now how is it bouncing off, right? It bounces off with how much force?
More force?
You tell me. Look at the number. We just said the force that it hits the
What's
wall.
the same force?
The
120.
same force, right? 120. For how long, though?
4 seconds.
Be careful.
0.4. 0.4.
0.4 seconds. So you have a what? You have a force and a time, right? So we could find the what?
Impulse.
Impulse. So what will be the impulse in this system?
You would do 120 times 0.4.
Mm-hmm. 0.04
rather.
Correct. So it was 120 times 0.04.
4.8.
Say it again.
4.8.
4.8, and that's the impulse, right? What did we say earlier? We said we said impulse is equal to what as well?
Momentum.
The what?
Change. Moment. Change.
Change in momentum. So therefore, impulse is 4.8, so the change in momentum must also be
4.8.
4.8, right? So now that we know the change in momentum is 4.8, I can say I know my change in momentum is equal to my final momentum minus my initial momentum. If I'm looking between P4 and P3, right? What is my momentum at P3?
0.
0, right? And I'm trying to find P4. But what is my change in momentum between P3 and P4?
4.8.
4.8. Therefore, if this is 0, then 4.8 is equal to
P4.
My final momentum. And the biggest thing too is making sure that we understand that it's negative because it's moving to the left. That's the only thing that I forgot. That's important. But it's negative because it's moving to the left because it's bouncing off. It just wasn't clear in the diagram. I just forgot to put it, but I want to make sure that you see that too. Now, the math, very trivial, right? And it can get confusing, but the most important thing that I really want you to take from this is each time you just have to examine the system and then make logic of it, right? If my tennis ball is not moving, obviously I can calculate the momentum and say that its velocity is 0, right? But if it's not moving, then it would have 0 momentum, right? Then it's acted upon by a force, right, over some time. So that's the impulse, the energy to just kind of make it move, right? So now with that impulse, right, that impulse creates it to now it's going to start moving, right? So now it's starting to move, and now what's the momentum of the object? It has a momentum. And then something's going to cause it to change the momentum again. What causes it to change the momentum? It's hitting a wall. Once it hits that wall, it's going to come to at least a stop because remember, we know from the first unit, right? Before you change direction, you do come to a complete stop and then go the other way. So we've seen that in unit 1, right? Now we're going to see that application that comes to momentum. For us to change our momentum, we have to come to a complete stop and go the other way. So that's this moment right here when we're coming, our momentum is changing, going to a complete stop. Then at the end of that, right? Now we bounce off and we go in the opposite direction. So we're going to the right, we hit the wall, and now we're going to bounce off, rebound off the wall, and go the opposite direction. So that's us seeing at the very end our momentum changing, but it's negative, which means we're going in the left.
Left.
Yes. Now we have these numbers, right? We're doing this math, right? But they're just explaining things that we see to the normal eye every day. If I throw a ball against a wall and it bounces off, you would see the same exact example. All we think we're doing differently is now calculating the numbers behind it. This is nothing new than what you guys already know. So let's look at the same example, right? Now we're understanding this, right? Let's dive deeper into this rebound effect, right? We're diving into this rebound effect. We could actually try and make comparisons between two different situations, right? And see which ones have the greater momentum, greater acceleration, and greatest change of momentum, right? So let's do that. We just did the same thing, right? Looking at this rebound case. So the diagram below picks the change of velocity of the ball that undergoes a collision with a wall. Indicate which case A or B has the greatest change of velocity, greatest acceleration, greatest momentum change, and greatest impulse. So support each answer, right? So let's do the first one together, right? Which one has the greatest change of velocity? A or B?
Which one has the greatest change in velocity?
Yes. And what is
B.
change of velocity?
It seems like B.
What is change of velocity again?
It's not momentum. Oh,
Change in
VF minus V1.
Good. So if I was to calculate the change of velocity for case A and case B, which one would be greater?
Are we supposed to be calculating them? Because if that's the case, it would be it would be 5 minus 28.
Think about it as individual cases, right? So in case A, what's the final velocity?
Oh, so it would be 5 minus 10.
Okay. And what's that
So it'd be
velocity?
5.
Positive or negative?
It would just be a regular 5.
Think about how it's changing, right? What direction is it going initially?
Right? Oh, because it's going back to, so it's right whenever it runs into the wall, and then when it stops and bounces back, it's 5.
Correct.
But if we take 5 away from that, wouldn't it go back in the right direction? I don't know. Maybe I'm thinking too deep into it.
Just say what it is. What's 10 minus, what's 5 minus 10? Positive or negative?
10 minus 5 is a positive 5.
Other way. 5 minus 10. Because the initial
Oh, then that's a negative.
negative. So then it would be positive or negative 5.
Negative 5.
Negative 5. So the first one's negative 5, right? Now with the next one, right?
It would be
What's
would
the final velocity?
28, so it'll be 28 minus 30. So it'll be negative 2.
Hold on real quick. Oh, real quick. Good thing I caught myself. Go back to the first case, right? We're going to assume positive is right, negative is left. Okay. My initial velocity is how much? In A.
Because your initial velocity is positive 10.
Positive 10, right? What is my final velocity?
It's 5. Negative 5.
Negative 5, right? What is minus 5 minus 10?
A positive 5.
Hold on. -5 minus 10. Or if I switch it to make it easier, right? -5 plus a -10.
-15.
-15. Only reason why I switched it is because sometimes you might get confused between subtracting from a negative, right? But if you understand you add switch to addition, right? I could switch the subtraction to addition, but that just means I have to change the sign of the number, right? But that makes sense that if I subtract from a negative, it would get more negative. So technically, -5 minus 10 is -15. So the change of velocity in the first case is actually -15. Now let's take that same concept for the second one, right? What is my initial velocity?
Positive 30.
+30. What is my final velocity?
-28.
So technically, what is my change of velocity?
I have no idea.
-58.
-58. So now for this one, right? The direction really does just kind of relate to, the negative just relates to the direction, right? They're both going in the same direction. So technically, which one has the greater magnitude if they're both going in the same direction? B or A?
Would it be A?
A is -15 and B is -58.
I mean, so the magnitude would be B because it's 58.
B,
Negative
right?
58.
And the reason why I say B is because they're both going left. So which one has the greatest change of velocity? Now,
B.
B, yes, correct. So this one we have is going to be B. So that was the math behind it, right? So now let's look at this, right? Now let's get into the logic, right? B has the greatest change of velocity, right? Let's assume, and can it tell us? Let's assume that it's the same ball, right? B has the greatest change of velocity, right? Therefore, if it's the same ball, then will the balls have the same mass?
Huh? No. I mean, yeah, the balls will have the same mass.
It's the same mass, right? So in case A and B, we could say that the mass is consistent, right?
Yeah.
So let's assume that these scenarios too also happen at the same time, right? The same time, right? Therefore, right, if we're looking at this, right, let me pull this out here. Acceleration is equal to change of velocity over time. If they happen at the same time, but have different change of velocities, how will we know which one has the greatest acceleration?
Whichever one has the greatest change in velocity.
So which one can we conclude would have the greatest acceleration by having the greatest also change of velocity?
B.
B. So we can say that B is going to have the greatest acceleration because it has the greatest change of velocity. Does that make sense?
Yeah.
You said yes or no?
Yeah, that makes sense.
Okay, so we're going to say B has the greatest acceleration. Now, let's go one more time. Now that we know that B has the greatest change of velocity, and it has the greatest acceleration. Let's look at change of momentum. Change of momentum is equal to what?
PF minus P1.
PF minus P1, and it's also equal to what else?
Mass times change in velocity.
Yep, that one as well. Now, what does that mean? If the ball is used in this both scenarios, right? That means the mass is the same. So we can say the mass is consistent. So which would create and determine if we have the greater change in momentum? If the mass is the same.
Whichever one has a greater change in velocity.
So between A and B, which one has the greatest change of velocity?
B.
B. So therefore, because B has the greatest change of velocity, which one will have the greatest change of momentum?
B.
B. So once again, B will have the greatest change of momentum because we have the greater change in velocity with the balls being consistent. Now, last one, right? Force times time is what?
Impulse.
Impulse. We said impulse is also equal to what?
Change in momentum.
Impulse is equal to change in momentum. So if an object has the greatest change in momentum, it also will have the greater what?
Impulse.
Impulse. So therefore, which object is going to have the greatest impulse?
B.
B. I included this one and I bet it fried your brains, but the way that it's supposed to go is you deductive reasoning to be able to put this together, right? So the first one is the only one we really did some math, right? We had to do some math, right? Actually finding out what that change of velocity was, right? Because it's going both in the same direction, which is left, we literally just look at it and we say, okay, we're going to just determine that the one on the case B is going to have the higher magnitude. So then it's 58 versus 15, which means B has a greater change of velocity. But after that, there is no math. It's pretty much using logic and deductive reasoning, right? We're going to assume that they have the same time for the motion, right? So when we see that, we know that the acceleration is equal to the change of velocity over time. So if time is consistent, the object with the greatest change of velocity will have the greatest acceleration, which is B. Then the same thing when we go to change in momentum. Assuming that they have the same mass, this ball has the same mass, what will determine the greatest change in momentum would be the greatest change of velocity, which we already determined in the first question is B. So now that means B will also have the greatest change in momentum. Then for the last one, right? Impulse is equal to the change in momentum. Therefore, whichever object has the greatest change in momentum will also have the greatest impulse. And we know that B has the greatest impulse. Sorry, greatest change in momentum. So therefore, B also has the greatest impulse. We did math in the first one, but after that, it was deductive reasoning to figure it out. So that's the same thing you wanted to do when you come to some of these problems. And honestly, give me 2 seconds. What I want now, as we get ready to come to the end tonight, look at this problem right here. I want you to determine the change of momentum. A 0.8 kilogram soccer ball experiences an impulse of 25 newtons per second. Determine the momentum of change of the soccer ball.
I was honestly really confused on the last one.
Let's go back. Where'd I lose you at?
The second one, when we started the second one.
The acceleration?
Yeah, like whenever we did the PF and the P1, and then you said go back to P equals mass time velocity. I don't know. I just got so lost after that.
So we know you got the first one that the change of velocity is greatest for B, right?
Yeah, so I got that one, that the magnitude was, what did I put? The greater magnitude was that 58, negative 58 was the greater magnitude going in the same direction.
Do you get the next one where you say that has the greatest acceleration?
No, I didn't understand the next one. Like the next little question.
Remember acceleration? Acceleration is equal to what?
Mass times
Nope, acceleration.
velocity over time or distance. I'm trying to think.
Hold on, don't guess. For change of velocity over time. That's important. Remember, change of velocity over time. Remember, I said that was the important thing, most important thing from unit 1. Acceleration is equal to change of velocity over time. So what does this mean now? Imagine the balls, each ball bounces off the wall for the same amount of time. We're assuming that, right?
Okay.
So if they both bounce off the ball at the same amount of time, that means that between both of them, the time is consistent. So if the time is consistent, which means it's the same, for one of these to have a greater acceleration, what variable has to be greater?
That's the part I didn't understand.
So
So
for
what
this, right?
variable has to be greater for what to happen?
Look, if I want this to be greater, right? Acceleration.
Okay.
This doesn't change. So I'm going to put this in red. This doesn't change. So for this to go up, what must I go up?
If acceleration goes up, then velocity must go up.
The change of velocity must go up. Therefore, we can conclude that the object with the greatest change of velocity will also have the greatest acceleration. Does that make sense to you?
Yes, hold on. So if acceleration needs to go up, so does velocity?
Because the time is the same. It's not changing between two scenarios, A and B.
Okay, so I got that. So the time can't change, but the velocity has to.
The
Because
time is
of
not changing because both of the scenarios, the cases are happening at the same amount of time. So the time does not change. Therefore, the object with the greatest change of velocity will also have the greatest acceleration.
Okay. Okay, I get that part.
All right, now let's move to the next one, right? So now, remember this one?
Yeah.
So now that we know that, right? Which object has the greatest change of velocity? I mean, what scenario? Case of A or B?
Hold on a second, because I gotta look at the answers we wrote.
Right here. Just look at the board. I mean, look at the slides.
Which one has the greatest velocity?
Change of velocity. A or B?
B.
B, right? Stay right there. Now, we already assume that they happen at the same time. We're going to assume that it's also the same tennis ball, which means that in each case, the tennis ball has the same mass. So if we say that, then same deal. Change in momentum is equal to mass times change of velocity, right? Which means that this mass is not changing. So for my change of momentum to increase, what also has to increase?
Velocity?
Change of velocity. So therefore, can we conclude that the object or case scenario with the greatest change of velocity is also going to have the greatest change of momentum?
Yes.
So now we get that for B. So which object has the greatest change of velocity? Sorry,
B.
B case. So therefore, B must also have the greatest change of momentum. Is that right?
Yes.
All right. Last one. So now that we know that, remember this, you said it earlier. What is this?
Impulse?
Impulse, right? Impulse is also equal to what?
Momentum?
Or specifically,
Change in momentum?
change of momentum. We already established that which one has the greatest change of momentum, B or A?
B.
B. And change of momentum is equal to impulse, right?
Mm-hmm.
So therefore, the greatest If the case has the greatest change in momentum, it will also have the what?
The greatest change in force or impulse?
Greatest impulse. So can we say that B is going to have the greatest impulse?
Yeah, because if one is B, then the other one has to be B too.
Exactly. Are we good
Okay.
now?
Yeah, I'm okay. Thank you.
No problem. Now, I'm glad that you spoke up and made me go through that, because now it really should take you 2 seconds to answer this question. So now, determine the change in momentum. A 0.8 kilogram soccer ball experiences an impulse of 25 newtons per second. Determine the momentum change of the soccer ball.
So do we do impulse, which is force times change over time?
Hold on. Talk yourself into it. Impulse is what?
Momentum.
Impulse is equal to what?
Change over time. So we would need to do
Oh,
change
change in what?
momentum.
Impulse is equal to what?
Momentum.
Say the
Change in
word.
momentum.
Change in momentum. Say it one more time. Say it exactly like that. Impulse is equal to what?
Change in momentum.
Say it one more time.
Impulse is equal to change in momentum.
Find a change in momentum in this problem.
So it'll be 0.8 times 25.
Go back. Impulse is equal to what?
Oh no, so it would be, this is confusing.
Fight with it.
Impulse,
No, fight with it.
change
Impulse
in
is equal to
momentum.
what? Say it again.
Impulse is equal to change in momentum.
Okay. Now that we understand that impulse is equal to change in momentum, how would you find the change in momentum?
P equals M times change in velocity.
All right. I'm glad that we're doing this. One more time. Impulse is equal to change in momentum. Say it one more time.
Impulse is equal to change in momentum.
What is given in the problem in the first sentence? We have two values given. What's the first one?
Mass,
Mass. What's the second one?
force.
Read it again.
I mean,
Read the word. What does that word say?
impulse. So it has an impulse of 25
Okay.
newtons per second.
Let's repeat what you just said earlier. Impulse is equal to change in momentum. Say it again.
Impulse is equal to change in momentum.
And we have an impulse of how much?
25.
So how would you find out the change in momentum of the soccer ball?
I would do 25 times. I don't know how I would do it because there's no time. So I would do mass. I don't know. I don't know how I would do it because now I'm confused. There's no time.
So think about it one more time. Impulse is equal to change in momentum. Say it one more time.
Impulse is equal to change in momentum.
Do you have an impulse?
Yeah.
They gave you the value for impulse. Impulse is equal to the change in momentum.
Maybe it's the way it's written that's confusing me because if I look at the formula and it's the sum of the force times the change over time, and then I look at the change in momentum, which is P equals M times velocity, it just confuses me.
This is perfect. I'm glad that this is happening because now we see what this is not about math. This is about you actually understanding the concept. I still need an answer. So what's the change in momentum?
I would say it's 25.
Stop right there. Yes. This is probably the most important part of today's lecture right here. Not getting caught up on formula fixation. That's going to show in the next slide, right?
Oh my God.
Yes.
You just said the answer. It's 25. It's just a tricky word problem. They gave you the answer in the question.
But what did it require you to understand? The concept of what?
Momentum.
Impulses, change in momentum.
Impulse is equal to change in momentum. If the first thing you do is go running to go ahead and try and plug in numbers into an equation, then it's showing that you're not really understanding what's going on. To make a simple mistake in a problem that was actually would take you 2 seconds. Wait, they already gave me impulse? They said change in momentum? Change in momentum is literally equal to impulse. So the answer is 25. That goes into the next part right here. And this will be the last thing we really cover tonight. And we'll start off with this problem tomorrow, right? Not tomorrow, Monday. Formula fixation, right? Formula fixation, this is a disease known as formula fixation that is common among physics students. It particularly affects those who perceive physics as an applied math course where numbers and equations are simply combined to solve algebra problems. However, this is not the true nature of physics. Physics concerns itself with ideas and concepts that provide a reasonable explanation of the physical world. When students divorce the mathematics from the ideas, formula fixation takes root, and even mathematical problem solving can become difficult. Do you have formula fixation? And that's literally what we just tested right now. And honestly, Courtney was very much brave enough to go ahead and demonstrate formula fixation in front of us, even though it was unintentional. But I know that a lot of you also go through the same thing. Don't try and remember the formulas. Don't try and just go ahead and just plug in things. Actually think logically. Understand the concepts, and then apply it to, like we said, what happens in the real physical world. You may have been tricked, but those were not intended as trick questions. The questions were intended to test your understanding of the concepts of momentum change, impulse, mass, force, time, and velocity change. So now what we determined from was doing these problems and talking about it, you answer to yourself, do you have formula fixation? And I'll stop there for tonight because I know this one right here is going to be a brain teaser, and I want us to start with this when we get on Monday. So battle with these problems over the weekend, right? Really try to do the best that you can to like go through them, but not just do them just to get the right answer. Actually try and understand the concepts. And if you don't understand it, do a couple more problems, because I only went through a couple of from each section, right? So there's more problems in each section, but go through them and really try to understand what's going on so you don't get caught up in just grabbing the formulas and just plugging in numbers, because this unit really is not so much about math. It's really about understanding the concept of what's going on. So it's more logical more than it is mathematical. But that's all I have for today. And I will post a link to an opportunity. I'll have an extra credit assignment, technically an extra credit opportunity. There is a quantum event over at Howard, and I will post a link to it on Blackboard along with the flyer. And if you attend and write and submit something that you learned from the event that happens on next Tuesday on the 14th, then I'll give you extra credit for this class. So I'll put all that on Blackboard, and I'll remind you on Monday as well too. But just know there's an extra credit assignment coming up to just go to an event over at Howard on the 14th, which is next Tuesday, this Tuesday coming up. And also just everything, like I said, labs 1 through 6 and practice problems 3 and 4 due on the 15th. Any questions?
No. So you said do labs 5 and 6.
One
Are we supposed to be doing 1 through 5?
1 through 6. Yes, 1 through 6.
Okay. And then the practice problems 3 and 4?
Make sure 3 and 4 are done by next week. Yes.
Okay. Okay, thanks.
Any other questions? All right, it's 8:30. I'll see you on Monday in person at 5:30.
See you later.
Thank you. Have a good night.
Have a good night.